Good day, everyone. My name is Vince Calvary Vistier. I am a first year electrical engineering student from Central Philippine University. Today, I'm going to teach you three topics of integral calculus. So, first is the length of the curve, second is the surface area, and the third is the centroids. Actually, I've already taught you all of these three because my past videos, I already taught you the topics of length of the curve and surface area, and we're just going to add centroids. So basically, this is only a review. So our learning objectives for today is to determine the length of a curve y equals to function of x times y equals to function of x between 2 points. Next, to determine the length of a curve, x equals to g of y times x equals to g of y between 2 points, and to find the surface area of a solid revolution. So the principles. We use definite integrals to find the arc length of a curve. In calculating the arc length of a curve, defined as function of x. Then we examine the same process of curves defined as function of y. This process is identical with the roles of xx and y reversed. The techniques we use to find the arc length can be extended to find the surface area of a surface area of revolution. And we close the section with an examination of this concept. So what is the length of the curve? The length of a plane curve by adding up lengths of linear segments between 2 points on the curve. So we have two examples of the length of the curve. So first, what is the area bounded by the curve y equals to x squared minus 1 and y equals to 2x plus 7? So here, first we had look solve for the plots so that we can intersect the graph, and we integrate the two functions y equals to 2x plus 7 and y equals to x squared minus 1, and the limits from -2 to 4, which are the intersection, the plot. So I have at the end of this video, I will show you how I solved the length of the curve and these two examples. So number two, find the volume of the solid obtained by rotating the area between the graphs of y equals to x squared and graphs of y minus x squared and x minus 2y around the y-axis. So these are the points, and these are the solvings that we're going to discuss at the end of the video. So what is surface area? Surface area is the amount of space covering up the outside of a three-dimensional shape. Again, we have two practice problems, and at the end of the video, I am going to show you how I solved the surface area of a cylinder and the surface area of a cone. So this is the graph, and these are the um, solutions I used to solve the surface area of the cylinder and the cone. So centroids. A centroid is a weighted average like the center of gravity but weighted with a geometric property like area or volume, and not a physical property like weight or mass. This means that centroids are properties of pure shape. So we have two examples of centroids. First, find the centroid of the area under the curve y equals to a minus x from x equals a to x equals 0. So this is the graph, and this is the solution for our problem. And number two, compute the coordinates of the area centroid by dividing the first moments by the total area. So here in the example number two, we're just going to solve the mean of y and the mean of x. So I'm just going to show how I solved the 54.8 millimeters and the 36.6 millimeters. At the end of the video, there will be a tutorial video how I solved the centroids of number 1 and number 2. So thank you for listening, and I hope you learned something, and God bless everyone.
So hi everyone, today we're going to solve two practice problems for the topic length of the curve. So the first problem, what's the area bounded by the curve y equals to x squared minus 1 and y equals to 2x plus 7. So first we're going to find the points of intersection. Given y equals to x squared minus 1 and y equals to 2x plus 7. We're going to use FOIL method to solve, so the answer is equal to x squared minus 2x minus 8. Next, if using the intercept form, we'll factor it out, so x minus 4 and x plus 2. So if x minus 4 is equals to 0 using the zero intercept form, so x is equals to, if x minus 4 is equal to 0, so x is equals to 4. And if x plus 2 is equals to 0, so x is equals to negative 2. Now we're going to calculate and integrate. So the integral of 4 negative 2, the integral of 2x plus 7 minus x squared minus 1 with the limits of negative 2 to 4 dx. So equals to, again combine this one, so the integral of 2x plus 8 minus x squared with the limits of negative 2 to 4. So integrate, so 2x becomes x squared, positive 8 is equals to 8x, and x squared, the integral of it is x cubed over 3. And the limits are 4, negative 2. So equals to, substitute for 2x. So equals to 4 squared plus 8 times 4 minus 4 cubed over 3, and substitute 2 to the other, to this one, to the term. So minus negative 2 squared plus 8 times negative 2 plus, minus, sorry, so minus negative, again, negative 2 cube over 3 equals to, so this becomes 16 plus 32 is equals to 48 minus 4 cube is equals to 64 over 3. So negative 2 squared is equals to 4 plus 4 times negative 8 times negative 2 is equals to negative 16, and negative 2 cubed is equals to 16 over 3. So this becomes positive. So combine equals to plus 12 minus 8 over 3. So the answer is equals to 60 minus 72 over 3 equals to 60 minus 24, and the final answer is equals to 36 square units. Now we are going to graph our answer. So the graph of x squared minus 1 and 2x plus 7 will look like this. So the points are there. And we're going to graph. So this is the graph of the given function y equals to x squared minus 1 and y equals to 2x plus 7. We're just going to put some vertical strip here. Label it. The thickness is dx. The distance is equals to x. The height is equals to y, and shade the area. So there we go. Problem number 2. Find the volume of the solid obtained by rotating the area between the graphs y minus x squared and x minus 2y around the y-axis. So first, the axis of rotation is on the y-axis. We are going to graph y minus x squared and x minus 2y. So the graph of y minus x squared is equals to just like this one, and the graph of x minus 2y is this one. So we're going to draw a vertical strip, and the area we're going to shade it. The height is labeled y. The thickness is labeled as dx, and the distance is labeled x. So this one, graph of x minus 2y, and this one, y minus x squared. Now we're going to solve. So if we notice, the two curves intersect when x squared equals to x over 2, so meaning the intercepts are x equals 0 or x equals to 1 over 2. Now we're going to solve. So the integral of 2 pi x using the formula of the volume 2 pi x times y dx. Now we're going to substitute it. So x squared over 2 minus x squared dx with the limits of 1/2 over 0 to 1/2. So put 2 pi out. They are the constants. The limits are 0 to 1/2 and integrate. This becomes x squared over 2 minus x cubed. So I forgot the given is x over 2 only. So if we integrate, it becomes x squared over 2 minus x cubed dx. So put 2 pi out again, then multiply and integrate. So this becomes x raised to 6. Wait, I'm sorry. So this becomes to x cubed over 6 minus x raised to 4 over 4. And the limits are 1/2, 0. So it is equals to 2 pi times 1 times 48 minus 1 over 64. Then combine 1 over 48 minus 1 over 64 is equals to 1 over 192. And the final answer is equals to, cancel this one, so pi over 96. And also we're going to rotate this vertical strip. So this is the image as a symmetrical image of y minus x squared and x minus 2y rotated around the y-axis. Now we're going to solve for the surface area. Practice problem number 1. Find the area of a cylinder with a radius of 7 feet and a height of 11 feet. So we're going to graph first. So the height is equals to 11 feet. So until here, so approximately here, the radius is equals to 7 feet. So here. So if we multiply it not to 2, so equals to 14 feet, and here is it. Now we're going to graph. Now we're going to solve for the given. So the surface area of the cylinder is equals to L equals to 2 pi times the radius and times the height. So L equals to 2 pi, the radius is equals to 7, and the height is equals to 11. So multiply it. 7 times 11 equals to 77 times 2 pi equals to 154 pi. So convert it to decimal form. So L equals to 483.8 feet, square feet. This is the answer. So here we're just gonna adjust the graph. So this is the surface area. And this is it. Second problem. Find the surface area of the cone with a radius of 6 centimeters and the height of 18 centimeters. First, we're going to graph a cone. We're going to create a cone. So the surface area, the height is equals to 18 centimeters and the radius is equals to 6 centimeters. And so we're going to double it. So there you go. Now balance and connect. So the two radius is equals to 12 centimeters, the width, and the height is equals to 18 centimeters. Now we're going to calculate the surface area. So we're going to find first the length so that we can find the surface area. So L squared is equals to, the radius is equals to 6 centimeters. So we're going to square it, plus 18 squared as the height equals to 36 plus 324. So if we add this, 36 plus 324 is equals to 360. So if we're going to find the length, so we're going to square root it. So the answer L equals to 6 over 10. Now we're going to find the surface area. The formula is equals to pi times the length plus pi r squared. Now substitute. Pi times radius is equals to 6. The length is equals to 6 square root of 10 plus pi times the radius 6 squared. So the answer is equals to 470.7 square centimeters. And this is the surface area of the cone. Now the last topics are centroids. So we're going to solve two problems. First problem, find the centroid of the area under the curve y equals to a minus x from x equals to a to x equals to 0. First, we're going to graph. We are going to create the graph of the centroid. So y equals to a minus x. We're going to, so this is the graph. Now we're going to put a vertical strip here. So the height, we're going to label it as y sub c, y over 2. And the distance labeled as x sub c equals to x. So this is y. I mean this should be the y sub c, the middle part. Now the thickness is labeled as dx, and the distance again labeled as x. And this one, the distance from here to the Cartesian plane, is labeled as a. So we're going to extend this. And go. There. Now we're going to solve the mean of x and the mean of y. So a x sub c over a total equals to, the limits are from 0 to a. So xy dx, so x is equals to b over a squared x squared dx. Then substitute the limits equals to b times a squared and x raised to 4 over 4. The limits of a to 0, and the answer is equals to a squared b over 4. Next, solving the mean of y. So still the limits are from 0 to a, and 1/2 times b over a squared x squared dx. Then substitute and solve. So b squared over 2a raised to 4 times x raised to 5 over 5 with the limits of a 0 to a. And the answer is equals to ab squared over 10. Now let's evaluate. So x mean is equals to ab over 3, which is equals to a squared b over 4. So x is equals to 3/4 a. And y equals to, same again, ab over 3 equals to ab squared, which is this one, over 10, and the answer is equals to 3 over 10b. So for number 2, we're going to compute the coordinates of the area of the centroid by dividing the first moments by the total area. So first, we're going to create the graph. This problem I just found it in the internet, and we're going to solve it. So the graph given in the internet is about this one. This is the center, and I'm going to connect this one. So there. So there is a point. This one, the distance will be labeled as x, and it is equals to 54.8 millimeters. 54.8 millimeters. And this line the height y mean is equals to 36.6 millimeters. Then shade the area first. Now we're going to solve how we're going to calculate on how this given points were solved. So x, the mean of x is equals to the summation of mean of x times the area over the summation of the area. So equals to So in the internet, there is a table, but as of now, I'm just going to paste the table on the video, and I'm going to show you uh, how they find the given. So here, so the summation of the mean of x times area is equals to 757.7 times 10 raised to 3 cubic millimeters over the summation of the area is equals to 13.828 times 10 raised to 3 square millimeters. So um, the area, the mean of x is equals to 54.8 millimeters. And now we're going to solve the mean of y, which is equals to 36.6 millimeters. So again, the same formula, mean of y equals to the summation of mean of y times area over summation of the area A equals to 506.2 times 10 raised to 3 cubic millimeters over 13.828 times 10 raised to 3 square millimeters. So we're going to divide, and y is equals to 36.6 millimeters. This is what I mean. I will just put the table on the video, and you will just identify the given and solve for the centroids of the area. So guys, thank you for listening, and I hope you have learned something, and may God bless you and enjoy your day.